Okay. Alright, so suppose for today, we should cover the theory parts whereby we should learn about the basic fundamental on IoT prerequisite knowledge, which is on the Kirchhoff law, parallel and series circuit, the relationship between voltage, ampere, and resistance, right? So we don't have to go further, right? It's just enough for us to know about this because all the boards are ready-made. We just make use of it, right? But digital and analog signals are important, right? So that you can differentiate between analog and digital signal, right? For example, our input digital, we use our push button, right? While analog signal, input signal, we use our potentiometer, right? So the result of analog input can be varies from 0 up until 4065. Meanwhile, digital only consists of 0 or 1, right? Right, okay, then, yeah, the theory part on the morning. Then we go into digital analog input output, which is we have covered that. Then I/O monitoring using serial monitor and serial plotter, same as well. Kita dah cover dah, alright? So we have few things more, sensor implementation. So all this while we have used LED, we have used push button, we have used potentiometer, right? So based on potentiometer, we should create another program, right? Okay, before we implement our sensor, right? So we should play one more round using our potentiometer. All right. Okay, let me go through this. All right. So as I mentioned earlier, that analog value depend on the ADC number of bits. Right. So for this case, our ESP32 using 12-bit ADC. Right. So that's why we reach up until 4095. Right. So even though the ADC provide the analog value, it not uh, it not necessarily accurate, right? So if you can see that this is lah baru turn on. Dah. Okay. Alright. Okay. So even though ESP32S or ESP32 provided with ADC, analog digital converter, the result might not good as the theory. For example, theoretically the line should be straight like this, but the one that provided by ADC might have a little bit distortion, right? Even though like this, it still able to provide, I would say, accurate reading. Okay, right. So when we apply sensor to our ADC on our ESP32, there are various state, right? So for example, let's say that 0, meaning that no reading at all, right? Or even the highest, the maximum value, no sensitivity. But in between these two low and top value, there are changes of value. So the changes of value depend on the sensor or the environment or the parameter or what element that we want to measure. For example, let's say water. So it will measure water. Is it a lot? Is it just a little? So the various value of water will apply to this analog value. Okay? All right. Okay, so let's create another one. Okay, so we have value of 0 up until 4095, right? So for us, let's do 0 until 1000, LED 1 high, 0 1001 up to 2000, 2500 lah. LED 2 high. So the balance 2500 2501 up to 4095, LED 1 high, right. Okay, faham ke? So if you apply if 0 up to 1000, else if 1001 up to okay. So this is the value of analog value lah, analog potential meter. Do you think you can do it? Boleh ke tak? Boleh. Alright, good. What is this? Okay. $39, is it? 6. Right. If you notice that when we use analog, we do not declare the pin mode. Right? Only digital we declare the pin mode. Okay? Right. So we declare the potentiometer 36. So maybe we want to use another variable called value A, analog. I think you guys already done this, right? Let me okay. declare. Alright, okay, done. So, based on the value A, we should do the thresholding. Holding. Okay, so over here, mana ni? If value A more than 0 and value A less equal than 1000. Sama macam programming kita lah. Kan? So, apa dia? Digital write LED 01 high, then digital write LED 02 low. Okay? Alright, so let me give you another LED. Oh, Afiq boleh, Sarah boleh tolong check kan ada orang nak masuk tak? What's up? Huh? Hmm? LED 2, you haven't declared yet. Huh? Yeah, still. Nah, LED. Tak payah guna sistem. Repek lah. Terbakar lagi. Oh,
Thank you.
sambil marking ya macam. Hah? Nah, add another 2 LED. Wait, I take some more. Ya. Hah? Tak tahu. Try je lah. Kalau terbakar kita pakai. Betul? Tak tahu? Kita try lah. Ya. Nah, cukup. Ni ya. Add another 2. Biasa apa? Tak siap lagi? Sarah ni. Okay, done. Who else? Sini siapa? Okay, done. You got extra LED, right? Okay. Oh, dahsyat. Right, I think you know the drill, right? So we have two LEDs. So you might connect to 16, you might connect to 17, 22, 21, up to you. Right? I think I no need to give any specific pin number. All right. So let me do mine. Right. Buat eh. All right. Okay. Okay. Huh? Oh, this one. Salah. Right, yeah. Yeah. Pin dekat dalam Teams tu ada. Ha. Ha? Apa dia? Oh, ni. Ha. Kenapa? Sama je. Alright. Not necessarily need to follow mine, yeah. It's just that LED to digital input output. Potentiometer to the analog. Oh, okay. Tambah, Celestine. LED 1, add up. Define LED, LED 0, 2. Okay. So, maybe you can add here the LED. Try. Tambah. So, there will be 2 pin. Yang the long one, positive Boleh? Just put it here. Put it here. Anywhere here. Okay. 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 So the long one on the right, is it? Okay. Take one jumper. Okay. Connect the long one. Yeah. Yes, correct. Betul. Connect to the pin. Pin what? Which pin that you want? Maybe besides the green one? Yeah. I think that one is 17. Besides, yeah, sebelah dia. No, 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 on other side. Okay. Boleh. Okay, yes, correct. Right. Then take another one. Ground. Oh, on the yeah. Sebelah dia ni. Di sebelah dia. Yeah, correct. Okay. Okay. Then ground kan lah. Mana ground? Still remember? Yeah. Any of this empty slot. Ya, betul? Okay, tadi yang sebelah ni pin berapa? Hmm, this one. Tengok dekat sini. Oh, 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 oh. Tadi pakai apa? 16 kan? So just now 17. Okay? So kat sini 17 lah. Alright. Okay. Mana LED? Oh, dah tambah dia. Okay. Listener okay ke? Done. Wah. Okay, meh? Bodoh gila, tak ada label. Tergabuk lah tu, bukan susunan. Kan? Ha? Ha? Oh. Okay. Done? Okay, sekejap eh. Alright. Okay. Okay. We use 3 LED eh. Eh, ni mana? Kau tengok currency pula ni. Tak ada, ini buat sendiri. Kita nampak kembang. Ni. Okay. Okay, kat sini lah. If buka, kita ambil value A ya. Value A lebih tinggi daripada kosong dengan value A kurang daripada 1000. Okay. So apa kita nak buat dalam condition ni? Kita nak turn on kan? Kita turn on kan LED? LED apa? Digital right. LED 1. Hai. Okay. Tapi LED 2 kita padamkan. Kita padamkan dulu. Okay. Lepas tu yang condition kedua else if lah. Else if buka value A kurang lebih daripada 1001 dan value A kurang daripada berapa? 2500. Okay. Buatlah condition kedua apa dah? Position kedua, LED 2 menyala. LED 1 padam. Tak pakai. Nak combine boleh lah. Mana Din? Done already or not? Belum test. Test. Tu pin berapa?
Itu dua
Ni
satu betul
negatif
tak?
kan? Yang ni pin berapa?
Itu 21 betul tak? Ni
21. Betul ke? 1, 2, 3, 4, 5, 6.
6 ya.
Okay.
Then
Oh. Okay. Kejap negatif sini kan? Dia kena.
ini tu.
Bukan. Dia kena. Dekat sini dia putus.
Kenapa?
Dia memang breadboard punya macam tu. This one
Negatif.
until half only.
Oh,
Until here. Mana? Yang ni kan negatif ni until half only.
half yang
Then
listrik.
another half
Dia kena
dia kena jump ke sana. Cuba try sekali lagi. Betul? Tak boleh juga. This one supposed to be the brown one is negative, right? Terbalik.
Oh, terbalik.
Okay, cuba try.
Oh,
Okay. Okay, welcome. Alright, done. Danny? Okay. Alright. Tak buat ke? Done already?
Yeah, can function properly.
Okay. How about you guys? Okay? Good. Dah ke? Alright. Awak nak present Okay. So yeah, it's supposed to be like this. Kalau kita threshold kita bawah 1000 dia satu je menyala. Then 1000 up to 2500 another one menyala. dan up both menyala. Okay? Boleh? All good? Okay. Cuba. Kan anak? Okay. Cuma program lain lah. Okay. This is zero. Zero. Tengok ni. Mana? Mana reading? Okay. Tengok. This one is it? This one. Okay. Tengok reading eh. Okay. This start from zero. Up until 1000. Dia tukar nampak? This is 600. 1000. So, state number 2 lah. So, when up to 2500. Menyala. Okay? Right. Okay. Okay, Didi. Push mark. Ha? Kemah. Oh, boleh buat lampu raya. Okay. Nazan. Siapa yang belum? Din. What happened? What are you trying to do? Okay. Never mind, slowly. We quite ahead of our schedule. You guys okay? Not okay with the code. C++ only. Why? What happened? Which one? These two, right? Okay, so this is ground. This is? This one what? Which one is positive? Which one is negative?
The left one is positive, right one is negative.
Okay. So this one should ground it here. Lah. Okay. This one is which pin? And this one?
16,
17, right?
17 or 16, 17.
17, 22.
Yeah.
Potentiometer working or not? Why got A?
Because I just set like if got
Oh,
value
okay.
like with it.
Alright, then okay. Okay, so this one terbalik kan? Low high B.
Like,
Kenapa above?
oh, yeah,
Lower lah.
lower. Okay. Oh, that's why.
Okay, let me check. This
This
one
one
also
also
lower.
that's
Okay,
why.
try lah. Right.
Oh, now it's B. B is
B. LED too high.
the left one.
This one. Ni apa?
Right one negative punya.
Betul ke 22? You confirm ke 22? Mana?
The 6. Yeah, the 6 one.
1, 2, 3, 4, 5, 6, 21 lah.
One or change 21.
Correct?
Correct. Yeah.
Both mana?
Both because the maximum I think is
Oh,
only until the
10.
yeah maximum. 转到 是转到最 maximum
Okay. 1, 3.
the maximum is until 1000.
Kenapa? This one is what? This one is power. Power. Betul. Ground. Ground. Okay. Okay. Sekejap. Sama juga. Yalah, tak apalah. Dan ni adjust sikit lah. Over 1000 ke. Alright, okay. Done. Alright. Okay, so basically, alright guys, listen. Right, so basically, when we move the potentiometer to various value, it will change the output, right? So, but in this case, we the one who control the input, right? So create another sketch to read a value from your LDR. Okay? Alright, sama juga LDR. The one that like this, then got like this. Ada tak dekat board tu? Ada kan? Okay. So connect that one to any ADC. Any ADC. I would like to suggest GPIO 36.
Do I need 4 wires for this?
3. Nah, Right. If you see the what we call this analog, right? Right. If you see the sensor, right, it has 4 pin, right? And this one is A0, this one is D0. Choose A0. We want analog. Okay? We only use one. Then we have our ground and VCC. Then we have our ground and voltage. Sama juga. Voltage connect to the VCC, connect to the power source, then ground connect to ground, and A0 connect to 36 or 39. Huh? Jumper. Okay. Mana Celestine? Betul lah. 36. Kat mana? Tu tengok tu. 36. Oops. Ni. Connect 39 lah. 39. So kat sini kan. 1, 2, 3, 4. Okay. This is 1, 2, this is 3. Beside dia. Boleh? Mata. Ha.
What is the maximum value for D?
Well, supposed to be for
4,000.
yeah.
Buy 1,000.
I need to check again.
Right now can 1.5.
Oh. Tak ketat kot.
So just now I just adjust scope sini lah.
Mana? 18 pula.
Ha.
This must be about the component kot. Component done. Okay? Alright, okay. Dah baca dah analog. Analog lampu. Analog lampu dah baca. So how the code? Yeah, basically just baca je lah Define this what we call as a LDR. So mine I'm using 39. Okay, integer LDR value. Okay, this one serial begin 11520. Okay, this one LDR value equal to analog read LDR. Okay, this one maybe I want to put delay 200 lah. Okay, then I would like to display the value, which is I need my serial print line. LDR value. All right. Okay, let me try to run. Okay. Alright. So, susah sangat lah. Okay. If you can see here, the value is 600. How about yours? Mine is about 600. Your LDR value?
How come I cannot upload this one again? Okay.
Hmm. Huh? Satu je. Never mind, copy, highlight all. Control C. Okay, just shut it down. Okay, open again. Open device manager. What? Okay, COM3, ESP32. No. Ada. No, not that one. Up, up, up. Yeah, this one. Here. 3. Okay, once again. Okay. Alright, open the serial monitor. Okay. Just tutup kan sensor tu. Close it by your hand. Yeah. Alright, okay. Open. Okay, put the light to the sensor and see the difference. What's wrong? Hmm, ni tak cocok. Dah. Okay. Search again. Jangan padam. Okay, search the board. ESP32. Oh. Yes, correct. Okay. Okay, try upload. Ada error. Okay. This one rapat kan? Don't have space in between. Okay. Once again, upload. Okay. Open your serial monitor. Alright. Okay, good. So which one is the sensor? Which one is the sensor? Yes, correct. Tutup. Seriously, tutup. Use your finger. See the value? Macam ni kan? Gelap kan? See? The value will be, kalau turn off this one, never mind lah. So put your phone light to the sensor and see. Macam ni. Flashlight, put the sensor. See the value? Sama je. Ni tak habis connect lagi ni. Just one wire, ada 3. Voltage and ground. Boleh? Try to connect first. Ada sensor. Mana? This one, why 2 wire only? Got 3. Okay or not? Okay, tengok ni. Right. So kau tengok situ eh. Let me take it out first lah eh. Right, okay. So basically we have A0, D0, GND, ground, and VCC. Right? So this is pin number what? Huh. Okay. Let's say that you take this one lah eh. And this one you put aside this one. Tengok pin map ada berapa? This one for who? Hmm. Okay, wait. Alright. So this one I make it number 3, 36. Ingat tau? Okay, 36. Right, what else? Power. Dia perlukan power. So we connect here, then we take the power from here. Can? Okay. Then another one, they need a ground beside the power. Okay. Then we connect to the ground here. Mana? Ada lagi? Jumper tak ada. Let me take. Oh, okay. So dia perlukan ground. So you connect ground and connect to the ground. There, menyala already. Okay, this one tadi apa? 36. Correct. Okay, tengok program. Buat barulah. Buat baru. Okay, declare. Wait. Okay, declare the pin first. H define, LDR, space, 36. Okay, enter. Integer, LDR value. Okay, semicolon. Alright, semicolon lah. Okay. Then, in setup, apa dia? Serial begin. Open bracket, 115, 200. Semicolon. Okay. Dekat sini. Apa ni? LDR value equal analog read. Open. LDR. Okay. Okay, enter. Serial print. LN. Open bracket. Apa? Yes, correct. Okay, bagi delay. Delay 200 millisecond. Okay. Oh, betul lah. Oh, ya. Okay. Tengok apa jadi. Okay, buka serial monitor. Right, so the value is 100. If you close it, jadi berapa? 1000. If you open, 100. Tutup. Berapa? 900. If you put the light here, so if you sikit-sikit saja. Right? Okay. Done. Macam mana? Kosong. Not chat done this. Ada 3. Supposed to be, nak jumper. Sekejap. Okay. Is there any different? Tu. Okay. Tu. So if you close it with your hand, berapa value dia? Is it high? Tak berapa high lah, boleh lah. Okay. Okay ke tak? Oh, betul. Ada Amir di sisi. Oh. Betul? Dia gelap dia nanti aku switch off lah Amir. Baca reading real lah, real reading. Tak tadi bilik tu kunci balik ke? Nak screwdriver.
Pasar.
Ha?
Kalau cari itu pasar.
Pasal?
Tak declare.
Tak declare? Then how come you get the reading?
Dia tak boleh pergi 4,000. Tapi dia boleh
Which one?
That's why because you guys see me
Oh,
meter.
suppose suppose tak apa. Alright. Okay. Alright, okay. Everyone done? 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 Kayo, sudah.
I really connect like this one.
Kenapa tak buat baru? $22?
Third one.
Mana? Third one mana ada analog?
That. Oh, so I need to put
This analog. ADC, ADC, ADC.
ADC.
36 ke? 36, 39. Put beside this. Put beside this.
So this. So
39. Hmm. Buat baru lah. Oh, sakit
Ini
ni
semua tak
mata.
payah. Ini one, value one until adik.
Tak ada apa pun. Aduh. Ni tak complete lah. You need to have another wire. Take it. Take from there. Outside, outside. This one. If you have a look, right? Ada A0, D0, ground, VCC. Alright? So this one is what? This one? This one is ground. Should be here. This one is ground. Okay. Then red color is ground. Then you should put then the power should get it from here. The power. Okay. Then now you connect. That's the why 39.
No input.
Oh, this one is value.
Oh, this, yeah. Okay, that's why. Okay. Value. Value okay. Okay. Fine.
Eh,
Okay. Got it.
right. Okay. So if you close it, it become higher. If you open, 300. So if you close properly with your finger, higher. Your phone got lamp or not? Okay. See. Put it directly to the. See, the value is. Okay. 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 You guys, okay or not? Oh, yeah, let okay. All right. Okay. Okay, done. All right. All right. All right. Okay, listen. All right. So basically, we have reading, right, for LDR. If we close it by our hand, it provide a different value. If a normal light like this, it provide a different value. And if we put a light, it will provide different value. Right. So to apply a real case situation, we categorize into three. Bright, which is very bright, kan? Normal, and dark. Alright, some of you, the value might go 0 up until 3000. Or some of you might not go as high as 3000. It depends. Alright, so the next thing that I want you to do, read the reading when I turn off this light. Boleh? Read the reading when I turn off this light. Okay. Tulis berapa? Ready? Yeah. Thank you. Berapa reading? 2000 lebih. Mine is, this is mine. Okay, this is mine. 1800. Yours? This is 3000. Okay. Boleh? Tengok berapa reading? Yours? Okay. Take note And yours? Okay. Take catat Yours? 3000. Good. Very good. Yours? Wow, very fast. Wow, cannot see. Ayo. Macam mana? The reason itulah kenapa campur. How you want to read the value? Bacalah value. What is your value? 3000. Okay, good. Yours? Oh, under construction. Yours? Oh, dah program Berapa? 27, tinggi semua. Not bad. Alright, okay. So maybe we can open half, Mr. Kelvin? Half. Oh, half only, half. Half at the middle, alternating kot. Tengok jap. Boleh lah. Berapa? Apa dia? 800. Okay. Let me see mine. Berapa? Your second value is? Mine is 500. Okay. Buka semua lampu sekali. Alright. And yeah, almost the same. Okay. Yang ni tak nak lah. Okay, yang last kali ni you touch the lamp. Mine is 200. Alright. Okay. Alright. So when you want to do the if else, okay? If you want to do the if else, you need to take a range, right? So for example, this one, maybe you take extra. Okay? So meaning that the value you get just now falls at the middle of this range. Okay? For example, 500. 400 up until 700, for example. And this one maybe less than 400. Boleh lah. So yang ni maybe up until 1000. Yang ni pun up until 1000. 1001 lah. This is mine ya. Your reading might be different. Ada yang 3000 tadi. So categorize, allocate the value of this, the value of this, the value of this to occupy up until 495. Okay? Boleh? So, if the situation is very dark, apa nak buat? Apa kita nak buat? Dark. Turn on all LED. LED 1, high. LED 2, high. LED 3, high. Kalau normal, maybe one LED only. Kalau this one, semua low. LED 1, LED 1. Boleh? Dua, tiga, satu. Okay? Ya ke okey ni? Ha? Mana? Tengok. If bright, that one kenapa menyala? Huh? Why always? That one to which pin? Tengok. Hmm. Tengok. This one, is it all connected? Check balik. Ada 3 LED tak? 1, 2. This one connect to which one? Let me see. Kenapa ada jam-jam wire ni? Why got jam wire? This one dekat mana? This one dekat mana? This one. Okay. Okay. Cuba try. This one pin berapa? The white one. Pin berapa? 2, 3, 4, 5, 6. Is it? Is it number 6? From the no, from the top. Cuba kira. Pin number 6. Betul? 1, 2, 3, 4, 5, 6. 21. Okay. This one LED number 3. Okay. Let me try have a look. Okay, betul. Positive, negative. Ground betul. Okay. Alright. Okay. Dia akan on bila the value goes to more than 1200. Tu nyala ya. Tak apa. Alright. Then LED number 2. LED 17. Is it? This is right. LED number 2. 17. Correct. Is this to the ground? Yes, correct. So LED number 2 bernyala bila? Oh, sama juga. Okay. Okay, alright. Yeah, okay. Alright. Connect je, just connect. Yeah, okay. Wah. Kenapa 4,95? Why? Is it? I don't think that is the real value. Cuba check balik. Right, dah. Okay. Right, when I switch off the lamp, make sure all LED turn on. If not, you cannot go home lah. All 3 LED must be turned on. Okay? Right, good. All LED turn on. Okay. This one, why very low? This? Wow, blinking. Okay, good. Okay. Yours? Satu LED je ke? Only one LED, is it? This one? Why did not turn on? Need to be very, very dark, is it? Okay, yours? Turn on. Not very dark. Right, tadi okay? Kenapa tak okay? Ni, this one, make it 3000. Make it 3000. Okay, run again. Wait. Still uploading. Dah. Okay? Alright, okay. So in real situation, this situation can imitate night mode, right? So during night, kita tak ada lampu macam ni lah. So basically you can do your garage lamp already. Malam je menyala. Right. Why still menyala? Padam. Make sure padam. Good. Betul. Why still got? Okay, padam. Alright. So this is situation where what was it? We apply to the real situation, right? Sama je. If you notice, and in any light dependent resistor, meaning that any light sensor, no matter for cars, for drone, for smartphone, for any kind of devices, will use this LDR, right? If you see carefully, right, the symbol was like this. This one, then got symbol like this. If you watch carefully, almost all light sensor will have things like this. It's just a matter of you notice or not. Okay? Alright. Okay, boleh? All good? Right, okay. So we go into our last sensor, which is water sensor. Then we will do, maybe we do PWM first. Alright, okay. So this is another Alright, okay. So this is another program where we call as PWM, right? So we have covered digital input, we have covered digital output. We have covered analog input. Right? So right now we will go into analog output. Right? Okay. So this is how we produce analog output. All this while you will only get on or off, right? For the LED. But right now we will produce continuous result for our LED, right? So for this program, this is on the slide, yeah. For this program, you can see that we provide different value to the LED based on your potential meter. So please remember the potential meter pin. For example, mine is number 36. Okay? All right. So create a new sketch. Please get used to write a new sketch. If not, susah lah. Right? So the difference with this one, we have additional setting whereby we need to set a frequency, a channel, and a resolution. Right? So for example, let's say that mine define meter 36. So P meter meaning that my potential meter lah. Right? Then I would like to define my LED 16 and 17. I'm not sure either we can apply PWL on digital or not, but let's give it a try. Value A, value potentiometer lah, value analog. And value O. Okay. Then I would like to set parameter for my frequency 5000, constant integer LED channel, which is 0, constant INT, resolution to 8. So this one kita pakai 8 bits. Kalau 8 bits berapa maksimum? Berapa value maksimum dia? 2 power of 8. 255. For this one, I make both LED 1 and LED 0 to make the obvious difference between digital and analog output. Alright, done. So value A, value A to read potential meter. Right, then no, we only have one. Then if value A more than 2000, yang ini untuk digital. LED 2. LED 2 kita digital lah. Sorry. LED 1 kita digital. So LED 2 PWM. Right? So kita nak tengok side by side. Kalau digital on macam mana, analog on macam mana. Right? This pin depend kalau yours is different then should follow yours. Pin only different. Yalah. Okay. So dekat sini kita pakai we use one special function where we call it as a map. Kita mapkan value A 0495 and 0255. Okay, I will explain later. Alright, okay. So maybe I want just a fast delay of 100. Okay. Right. This one just make it squeeze it. I hope everything's just the same. And let's go. We have a look. Ada error. Oh ni, value 0. Alright, okay. So, yeah, my initial value is 4000. So, if you can see, the brightness will depend on the potentiometer. Right? So, if you light it up, it will bright, bright, bright. Okay? If you put side by side, digital and analog, you can see the difference. Okay? Boleh? Oh, let me just stretch the code. Okay. Sarah? Salah. Okay. Zoom sikit. Kalau zoom tak boleh tengok the whole code lah, tak apa. Zoom sikit. Okay. Alright. Frequency 5000. Buka ni. Serial monitor. Okay. Pusing. Pada okay, pusing. Tu. You see ni? You see that one? Okay, pusing lagi. Tu. Okay, turn it on. So this is digital and that one is analog. Bright a little bit more until the maximum. But digital only on and off. Pull until up 4000. Yeah. Okay. Afiq, Oh, dia macam ni lah guna je mechanical keyboard. Boleh tak I nak tukar kejap? Yang LED ni dia tak lawa. Okay. Okay. Cuba pusing. Okay. Alright. Okay. Alright, okay. So, did you get the value? Did you get how to control the dim? Maybe I want to change a little bit here. I would like to change 4000 and 4000. The reason why I would like to see the PWM more. Okay. Okay, alright. So basically it is like this ya. So dia akan bila turn on dia akan dim lah. Dim, bright, 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 bright. Tapi kalau digital on and off saja. Kalau PWM analog output dia ada stepping. Okay. Boleh? Right. Boleh? And of course you can, instead of an potentiometer, you can attach to your LDR and others lah. Always want to use the same. Is it the same? Same, right? LDR. Later you can't get the result. Okay. Turn. All right. Okay. Okay or not?
Fine.
Wah, why I got error? Show meter, P meter, value meter. Colon. Okay. Turn. No chat. Ya, turn. Tak jadi. Try to find out why. Push. Jangan meletup, jangan meletup. Bukan. Analog tak ada U. Analog UE tak ada. Dia Itali dia shortcut dia. Okay. Apa lagi ni? Value A, V besar, V kecil lah. Okay, run lagi. Okay, 6. Okay, siap. Pusing Alim. Kemah. Pasal apa? Tak on satu lagi? Yang FPWM tak ada. Okay, patut pin PWM pin berapa? 1, 2. 17. Patut 17. Orange. Orange ni. Ini 16, ini 17. Betul lah. Cuba try. Say cheese. Okay. Alright. Okay. Okay. Alright. Alright. Okay. So, what is map actually? What is map? Why we use map? Right? So, when we say map, there are 4 value. Am I right? So, we have 4 value if we want to use map. Right? Okay? So, for 2 first value is the range of input. Then another 2 value is the range for output. Range of output. Okay? So, when we put, we already know that our potentiometer goes from 0 up to 495. Right? And for the output, we go 0 up to 255. Kenapa 255? Kenapa? Sebab kita punya resolution, we set it as 8 bits. Alright, so that's why we get 255. Alright, so this is where we get our 255. Okay, so 255 here. So the first 2 parameter, the range of input, then the range of output. So when we draw a graph of map 0 here, right? 4095 here, 255 here. Okay? In order, if the value of input increase, the value of output also will increase. So the graph will be like this. Okay? So for example, let's say if the maximum value, so if the input for 095, it will produce the maximum output. If half of it, this one maybe 2000, this one might be 175. Okay? So move along based on the input, the output also will produce linear output. Faham ke? Understand? No. Yes. Okay, good. Okay? So the increase lah. This is the graph. Right? But how if we turn 0, 4095, 255, 0. Apa akan jadi kat graf dia? What will happen? What will happen? The graph will be like this. Betul? Okay. So it depends on the setup you want to do. So basically, why we use map? Because of we want the continuous output. Okay. Usually for LED lah. Boleh? Alright. Done. All good? Okay. So 255. Oh, tak habis lagi rupanya. Okay, if you notice, right, if you turn the, what we call it, potentiometer, right, if you watch carefully, LED tu dia akan ada something like that. Dia ada beep, dia ada macam ada beat. Okay. So as I said, the board will still communicate in digital, right? So instead of turn on all the way, kan? Instead of turn on all the way, how about kalau kita dim half of it? So we say that frequency is 5000, meaning that 5000 cycle in 1 second. Itu formula frequency kan? Okay, let's say we turn on off, meaning that within 1 second, there are 2000 cycle that be turned off. Am I right? In 1 second. So meaning that in 1 second, the brightness reduce 50%. But it cannot be seen using our eyes lah. Sebab dia ada 5000 cycle in 1 second. Okay? So this one, we call it as a 50% duty cycle. Okay? This one, we call it as a 100% duty cycle. Boleh? Okay? So you can decide how much for the duty cycle. Right? So this is might be 75%. So in between the digital, there are turn off. Right? So theoretically, it does not provide analog output. but we manipulate the digital signal to produce various output, continuous output, right? So, yeah, and this is how we get a dim, a full bright LED. Then we move the potentiometer until it turn off, right? Okay, boleh ke? Ada soalan? Tak ada. 4 o'clock already. Boleh? Okay. Ya, Terence, apa dia? Oh, boleh, okay. Alright. Okay. Let's say that we build a thing for plant. Okay. So usually plant, there are various aspects that we need to measure. Right? But this time, we need to measure first the water, then the sunlight. So I already provide to you the sensor of water. Yang ni yang macam garfu fork ni, sensor water. Then the LDR to measure the light, the sunlight. Okay. So maybe we want to start with water dulu. Okay, you can save it. So we try to use water sensor pula. Ni ada apa ni? Okay, kita pakai ni . So each of you boleh ambil this thing, then try to fold to your sensor. Okay. Alright, then connect lah. So I would like to use pin number 34 maybe. Reserve. Kenapa? Janganlah kepak monitor tu. Kenapa? LED C. C hilang. C, where your C? Ada. Right, okay. So you need a jumper, right? We need to connect the water sensor. Water sensor pun sama je. Any sensor lah, senang cerita. Mesti sama je. 3 wire juga. Nah. This one. Oh, dah ada. This one. Okay. Alright. So, sama juga water sensor ada. Kalau kat sini dia tulis 4 lah as usual. Kita ambil yang analog. A0 only. D0 we no need to take. A0. We try to connect with our 30. Saya nak connect 34 lah. 1, 2, 3. 34. Then power cable. Most right. Then ground. Dah menyala. Okay, let me tidy up a little bit my place. All right. Okay, I'm using 34. You guys can use any ADC you want lah. Right, so 34 define water sensor 34. Integer water value. Value W lah. Okay. Kabel lebih. Ni. Tisu. Sila ush. Dah ada apa? Serial begin 115200. Then analog read. Value W equal analog read water sensor. Alright, so I would like to read back serial print line value W. I would like to have little delay. Okay, done. Sikit je. Right, okay. Alright, so I ada water sensor. Okay, the value right now is 4,000. Right, so kalau I spray air, dia turun jadi 3,000. Okay, so let's say that I wipe it clean, dia akan jadi maximum value. Okay, kita try sekali lagi. Okay, dia akan jadi 3,000. Right? Panas pula. The Wait, connecting. The short skirt kot. Sempit lah. Can I move it? Maybe move it here. Okay. This one? VCC. No. This is? This is what? This is for what? 34 ke kat sini ke? Open. Dah, 34. This one, right?
Eh?
1, 2, 1, 2, 3, 4, 5. 1, 2, 3, 4, 4, 5. Here, right?
Yeah.
Okay, so connect to red color. Wrong. Okay. Then I take out these two. These two. This is what? Ground. Ground to which? Yellow. Yellow. Then this one is power, right? Power connect to VCC, green. Okay. There you go. Okay. Try to upload. Okay. Tadi tu short circle lah. So you go take one tissue, then you put it like this, then you spray water and see. Tengok ni. Serial monitor. Okay. Value berapa?
I use my hand.
Okay, move it. Do you know why? Because our hand also is conductor. Can kenapa hang? Because our hand also pasal apa? Dua? Tu lah aku dapat 3,000 lah. Pasal teruk lah. Pasal teruk lah. Mana spray tu? Why? No, this one. Semicolon. No water. Okay. You don't want to do it? Basah teruk. Our friend said kena basah teruk. So basah teruk lah. Ah, 2003. Right? If some more. 2003. I can get 2003. $1,800. Basah lagi. 1,700. Nah, siapa nak? Water. Carefully ya. How much? You just put it and okay, you just put it here. Okay. Okay. Just try to spray here. Okay. Try to spray here. And read the reading lah. If not, how you want to know the reading? Nah, low already. Let's say I take it out and wipe it dry, right? 4,000, right? So if you do it again, on the wax. Okay. Try to spray until soak with the water. Is it going down? Going down? Okay. So you can spray up until the lowest you can get. Very cocky ya. Okay.
This is
Dah, tisu mana tak ambil? Tisu dah. Make sure a little bit far from your board. Okay, open the serial monitor first. Okay, the current value berapa? 0? Apa benda ni? Aduh, banyaknya. Which one ni?
hold on.
Clean up your code. If not, I unable to read. I think you need more. You need more. More. Until soak. How about you guys? Berapa? 1,600. Okay. So meaning that kalau it goes up, right? Then you need to put some more water lah to the plant. Okay. Ada okay? Sleepy already. Your reading berapa? Ayo. Salah ni. Pin 34. Confirm? Betul. Ground. Betul. The red one. Power. Betul. So, what happened? Salah ni. Tengok. This is C. This is ground. This is 34 betul? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 34. Betul? Okay. Analog. Read. W. Scroll down. Ni mana nak keluar? W lah. That's why you need to do a new code. Stubborn Serial, okay. Wait. Okay dah. No chat.
Oh,
Okay. Tisu je basah Hak lain jangan basah. Berapa? Reading dia makin lama makin kurang kan? Dah naik lah 2,000.
Dia kena tu daripada atas ke bawah.
Dia sebenarnya kalau ikut kan dia celup ke air kan. Tapi in realistic situation, hang moist je. Tanah kan. Gitu sensor lah. Sensor brand apa? Cing cong cing. Tadi apa? Kau brand 1,000 cocok tanah je tu. Accurate lah. Tapi boleh lah. Dia kira cuma hang tak dapat lah sampai 500 kan. Dah sok gila babi tapi tak sampai 500 kan. Kawah. Tak dapat. Dia kena tune tu. Tune potentiometer dia. Dia boleh tune sensitivity dia. Tapi aku balas sampai habis pun tak dapat kak. Macam tu lah cerita dah. Lagi satu, tak tahu aku rasa operational voltage dah 5 volt. Tapi hang supply 3.3 kan. So dia tak dapat fully utilize lah kot. Kan range tu. Put first lah the sensor. Put the at the middle. Then lipatkan dia. So then you spray. Okay. Berapa reading? Tengok reading. Spray sekali tengok reading. Spray sekali tengok reading. Berapa? 400? Are you sure?
Broken.
Okay, try to dry it up. Do you have any tissue more? Okay. Nah, dry it up. Take out and dry it up. Okay, berapa value dia kalau dry? 4,000. Okay, 4,000. So kira tu kalau dapat rendah sampai 400. Berapa? How much? 400 juga. Salah ni. Salah ni.
Berapa?
Minimum I get 1,600. Okay. Mana? Excuse me. 15. Open back the pin out. Pin out got ADC or not? 15. No, lower. Oh, mana 15?
13. Ayo.
No, connect to here. Boleh lah 13. Try 13 lah if you want. Dry it out first. Okay, then see the value. Okay, no check. Okay. 4,000. Okay, soak it out. Okay, spray. Spray. Up until that is the minimum value. Okay, put the new tissue. Give it a new tissue. The dry tissue. Then spray a new tissue. Spray a new tissue. Okay, start from here. Tengok Oh, sikit-sikit lah. Okay, then lagi. Kenapa keluar masuk? See, it will drop. Mana? There. It will drop slowly, slowly, slowly until it has sufficient water. Alright? Okay. So the lowest I can get is 1,600. Right? Everyone get the same result? So by having this, you can threshold it using if else if you want, right? Or you can thresholding using map. It is up to you. All right, okay. So yeah, we will not cover this, but you can use for example, let's say that 495 LED light up. Maybe 2000 LED too high. 2000 LED 1 high. LED too low. Below 1000 dua-dua low. Meaning that it has sufficient water. Kan? Okay? If you want to do it, yes, you can do. But if you don't want to do it, then it is up to you. Right? Okay. Done. Right? So basically we can get that indicator lah. So basically we can get the indicator to indicate us, to tell us, is it the water enough? Or we need more water? Or we need less water? Or we need to stop watering? And so on. Right? Okay. Alright, okay, done. So, we can measure the sunlight and also H2O, right? Other than that, we need to find a different sensor, right? For example, let's say that you want to measure the pH level of the water. We need to have pH sensor. Let's say that you want to measure the wind. You need to have different type of sensor, right? It depends on your application. What kind of element that you want to measure, right? If you want to measure the humidity, the temperature, so it has its own sensor, right? So the one that we use today, it is a purely analog sensor. So when it is purely analog sensor, the reading might be different from one to another. Okay? Right. So basically what we have done here is the thing. This is a thing, right? So tomorrow we will go on communication, so that this hold a value, then we will send this value to other places, right? For example, let's say that you put this in your farm, then you at the college can monitor the value of the soil moist sensor, or even the light and so on, right? Okay, then that data we will log into our file. Alright, okay. Ada soalan? Make sure that whatever that you spray, dry it back. Okay? Alright. Okay, I think that's all for today. So, yeah, don't unplug. I don't know if you prefer to do it again tomorrow, then you can unplug everything. But anyhow, you can just biarkan sajalah atas meja. Right? Okay. Ada apa-apa soalan? What have you learned? What have you learned? Nothing. Nothing, is it? Right. Okay. So the very reason that why I conduct this training, right? Because you have learned C++, right? But you must be wondering, where should I apply this programming skill, right? So yeah, this is one of the example, right? So in software development is another example, in hardware programming is another example, and so on, right? So this is how you apply your skill, right? Before this, you has been briefed regarding digital and analog, right? Throughout the medium, throughout the networking medium, throughout the devices, right? But you can't see in real situation how the digital and analog works, right? So this is the reason why I conduct this training. You can see clearly in IoT application how to use analog and digital signal. Okay? Alright. So tomorrow, we no longer do the wiring, right? We only use whatever data that we have from our sensor, then we send it somewhere else, right? And we put it in a very nice view that we call as a data visualization or dashboard. Okay, so for today, I hope you guys have learned at least something, right? Basic electrical, basic electronic, basic signals, and how to apply a program, and how to control your devices, how to implement the sensor, how to produce the output, and so on. Okay? And everything that I show to you today, it is open source. So what is the meaning of open source? Public, yes. You can reach it publicly. So for example, let's say that you want to use analog sensor. You just can type analog sensor Arduino or ESP. So the document itself has produced by Arduino themselves. Alright, so this is what open source regarding about. They expose their source code, they expose their source so that we can use for our own good. Alright, semua ada. Macam mana nak connect, what is the program, and so on, semua ada. Okay, so this is the benefit of having open source platform. Alright, so even you said ESP32 Arduino IDE, it will provide to you. Even though it is not from Arduino itself, ada website-website lain yang boleh contribute. Okay? So, yeah, unfortunately, computer science tak ada final year project kan? Okay? So, yang e-business might not suitable lah to do this as their final year project. Okay? But, let's say that you have relative or siblings that interested to learn this kind of stuff, you might recommend them to study electrical and electronic, right? So pretty much this is what they will learn throughout the course. Okay, yeah, I think that's all for today. We finish a little bit early, 4:40, and we shall meet again tomorrow, right? So for your information, certificate will be provided. The name of you written on the certificate depend on the application form, registration form that you fill out before. So I hope you fill out the correct full name lah to be displayed in your certificate. Otherwise, please let me know. Right? Okay. Yeah, I think thanks for attending today. I hope I can see same face tomorrow so that we can continue our lessons. Jangan hilang esok. Alright guys. That's all. Bye-bye.